Once there's a ball is very happy in the outer space, but suddenly the earth comes and this ball is attracted by the earth to this point. At this point, the distance between the earth and this ball is r. And if you try to calculate the total work done by the earth in bringing this ball from very far infinity towards this point, it would be equal to gmm divided by r. And I am saying that the negative of this work is known as the potential energy of this system. Why? Why there's a negative sign? And why should it is known as potential energy? Let's divide this question in one by one. First of all, what is energy actually means? If you have a 5 joule of energy, then if you do a 5 joule of work, then your energy will lost and you have 0 joule energy now. Here we have energy, but it is negative. How can it be possible? If it is a positive work, then we can say that we can do that much work. But if it is negative, then what is that meaning? This means that we have to do this much work in order to bring the system to the previous case. That is, we need to do this much work against the gravitational field of the earth in order to bring this ball back to infinity. But there is a problem. If we move straightly to the infinity, like in the radial direction, we can say that this much work will use. But if I move in a zigzag motion, then how can I say about that this much work will be used? How can I prove that? I have a great logical proof of it, but before that, let's pause this video and try to think about what is happening there. How to prove that logically. I don't need a mathematical proof. I need a logical proof. Let's think about it. Okay. Let's suppose I draw a lot of circles like this, in such a way that the width of each circle is dr. And the dr is so small such that the gravitational field throughout each circle is same. Like if you take the yellow circle, the gravitational field along this yellow region is same. And if you take the green circle, the gravitational field along this green region is same. But the gravitational field between the yellow and the green are different. Now the game starts. If you try to calculate the work done in bringing a mass from the inner circle to the outer circle in two different paths, one is a straight line path and other one is a zigzag motion. And the work done in the straight line path is nothing. It is the difference between the potential energy. But what would be the work done in the zigzag motion? Let's look at the orange region. Let's suppose the gravitational field of this orange region is G1, and even though it is moving in this direction, the gravitational field is along the radial direction. So the net work done will be G1 dr. And if you look at the green region, the gravitational field, if we take it as G2, then even though it is moving in this direction, the gravitational field is radial. That's why G2 dr is the work done. And if you look at the yellow region, if you take the gravitational field as G3, then G3 dr is the work done. So togetherly, the total work done will be G1 dr plus G2 dr plus G3 dr. But wait, what is the work done when we are going in the straight path? It is also G1 dr plus G2 dr plus G3 dr. But when we are going in the zigzag motion also, it is G1 dr plus G2 dr plus G3 dr. Both are same. Here is the thing, we proved it. If you are going from one circle to other circle in very good way or in very utter bad way, the total work done by you against the gravity will be the potential energy difference between these two circles. That's why this work will be path independent. So this gravitational field, this force is known as conservative force. By using this concept, I am going into another example. If you take the outer circle as very big, like the radius of the outer circle is tending to infinity and the radius of the orange circle is r, and if you try to move a ball from this orange circle to the outer circle, then how much work you need to do? Yeah, we know that the potential energy of the outer circle is very small. It is approaching to 0 because the radius is approaching to infinity. And the potential energy of this orange circle is gmm divided by r, negative gmm divided by r. That's why the potential difference between these two circles will be gmm divided by r. So this much work I need to do in order to bring this ball to infinity. Yes, this is why I called it as the potential energy. In any way you can go from the orange circle to the outer circle, but you need to do this much work. Actually, we are on depth of that much energy. That's why I put a negative sign before the total work done by the Earth. We need to do this much work in order to save this bowl from the Earth's gravitational field.